Okay, so in continuation of the past lecture, I just want to give you one easy formula, which is known as chain rule combined with power rule. And this formula becomes very handy, and I give you enough number of examples about it. Now, this formula, I'm going to first write it down in the box here. Y equals u to the exponent of n, okay, where n is any real number. And then the derivative is n times u prime, u to the exponent of n minus 1. Okay, this is a result of actually chain rule if you combine it with power rule. And the chain rule, if you remember in Leibniz notation, it was dy over dx, which is equal to dy over du times du over dx. We said it in the past that derivative of y with respect to x equals derivative of y with respect to u times derivative of u with respect to x. Now, if you look at this example, y equals, let's say x to the 4 plus x cubed, and then minus 5 raised to the exponent of, let's say, 9. If you want to find the derivative of this function, you can say, okay, here the quartic function plays the role of u, and the exponent of n plays the role of n, right? The exponent of 9 plays the role of n. So following the formula, the answer would be n u prime u to the exponent of n minus 1. Okay? And n here is 9, and u prime is going to be 4x cubed plus 3x squared. And the exponent n minus 1 would be 8, obviously. All right? So, sorry, I forgot to write the u. So this was n, this was u prime, and now we have u to the exponent of n minus 1. So x to the 4 plus x cubed minus 5 to the exponent of 8, because 9 minus 1 is 8. So n u prime u to the exponent of n minus 1, right there in one shot you find the answer. So we could have done this using the longer way, using the FOG in that notation for the chain rule, but perhaps using this formula is much easier and it's like handy. I can do this question using Leibniz notation, chain rule Leibniz notation. I can say let u equal to x to the 4 plus x cubed minus 5. And I can say let y equal u to the exponent of 9. Okay, I can say that. So I'm expressing u in terms of x, expressing y in terms of u. Okay, and now I'm trying to find dy over dx. Okay, which according to the chain rule, it's dy over du times du over dx. But what is dy over du? Well, that's the derivative of y with respect to u, which easily you can say it is 9u to the exponent of 8. Derivative of y with respect to u is 9 times u to the exponent of 8. And what is the derivative of u with respect to x? It's going to be 4x cubed plus 3x squared. That's the derivative of u with respect to x. And according to the chain rule, we just need to multiply these two. Therefore, I'm going to say dy over dx is equal to 9u to the 8, okay? And then times 4x cubed plus 3x squared. That is following the chain rule in Leibniz notation. But the thing is that half of the answer is in terms of u, half of it is in terms of x. So it is better to express the answer in terms of x only. So I do a back substitution here. X to the 4 plus x cubed minus 5. I substitute back for u. The exponent is 8 times 4x cubed plus 3x squared. And this becomes y prime, or actually dy over dx in Leibniz notation. And this is the derivative of the function. Now, see, if you look carefully, I got the same answer long time ago, in like 2 seconds in only one line. That was my answer, right? So you see, you can get the answer using this formula, in one shot. It's fast, quick, easy, easy to memorize actually. But if you want to do it the long way, you can do it. Nobody says it's wrong. Nothing is wrong with this calculation. Everything is the same. The answer is perfectly matching. But we're just saying that this is like sort of shortcut method. it is not a bad idea to know about it. Okay, that's all we're saying here. Thank you for your attention.